I want to talk about the idea of climate preparedness, but it's something I can tell you that I've worked on recently in the context of a climate scientist who thinks about climate change on very long timescales, but also as a climate scientist who about a decade ago, kind of like Andy, but maybe a little bit earlier, started to realize it was frustrating to talk about climate change and not talk about what to do about it. And so I started working on energy technology and energy policy, and that occupies a large fraction of my time today as well. So I'll touch on all of that and try to bring all of this together. The first thing I want to do, though, is talk about the timescale of climate change, because this is something that I think a lot about as a geologist, something that some people kind of are aware of, some people are not aware of it, and it's a very stunning view of reality, unfortunately. This can be rather depressing. So this, everybody knows, the Keeling curve. By the way, we didn't really cross 400 ppm yet. That's next spring. We were at like 398. 400 ppm was a daily average that really is like air pollution from China on a daily thing. But next spring, it's an arbitrary value anyway, but just so you know, we're going to have a big party next spring as we enter the 400 ppm world.
That's a new approach.
We are. You can come. It's going to be up at Harvard in the spring. Let's talk about the timescale of the climate system for a second. We could talk about the timescale of the ocean and heat uptake by the ocean. We could talk about a variety of different things. Let's talk about the timescale of the carbon cycle. This is a figure I love from a paper by my friend David Archer at the University of Chicago. And it's a really technical figure. I want to interpret it for you. Look at just the top two graphs, A and B. The top graph is emissions in billions of tons of carbon per year, not CO2, that's carbon per year. And you have to pay attention to two lines, this thick gray line here and this thick black line right here. And each of those are emission scenarios. The gray one is 1,000 billion tons of carbon cumulatively, and the black is 5,000 billion tons of carbon cumulatively. For those who don't know, 1,000 gigatons, basically if we dramatically reduced emissions all over the world, if all the countries of the world got together and dramatically reduced their emissions now and got to zero by basically 2150 or something like that, or a little bit sooner, we would keep it under 1,000 gigatons. There's no chance that's going to happen. But that is the best we could possibly do in your wildest dreams. 5,000 gigatons is kind of like burning all the coal reserves in the world. So it's kind of, you could think of these two lines as the maximum and the minimum possible cumulative emissions. And what you see, and this is a model that David has done of the carbon cycle, which includes oceans, atmosphere, deep ocean, and reaction with carbonate sediments, and then ultimately reaction with rocks on the Earth's surface called silicate weathering, which takes a much longer time scale, takes a much longer time to happen. You see that in the worst case scenario, 5,000 gigatons, CO2 goes up to about 1,900 parts per million, and then comes down and plateaus around 1,000 parts per million. You've got to notice something, though. The time scale here is 2,000 to 3,000 AD, but the time scale for this one is actually longer. It's 2,000 to 12,000 AD. Okay, so the time scale of the response is thousands of years, and it plateaus at 1,000 parts per million and doesn't actually come back down to the pre-industrial level for about 100,000 years. Okay? If we were to do everything we could to reduce emissions, everybody collectively around the world, we would come back down in 500 to 1,000 years down to about 400 parts per million, the level we're almost at today. And then we would stay there for tens of thousands of years, slowly declining back to pre-industrial levels over the next 100,000 years. Okay? I didn't say this was going to be uplifting, the beginning at least. So how do you think about something on this kind of time scale? How do you think about the fact that the choices we're making today are affecting the Earth, not for, we say it's our children and our grandchildren. No. We're talking about affecting the Earth for thousands of generations. It's kind of hard to think about. The timescales of this system are really long. So how do you think about the value of the distant future? What do we think about decisions we're making today that will affect the Earth for tens of thousands of years? Is there a moral argument for some threshold of environmental conditions we must preserve for future generations? All really interesting questions. I'm not going to deal with them today. but I want you to have that in the background as we talk about this. Another important timescale, the climate system, the response to CO2 is really mostly to cumulative emissions. This is something that most climate policy people don't really understand. Even if they say they do, they don't. And the reason is they focus on short-term emissions targets. The question is not how low we get in 2020. I don't care whether it's a 20% or a 30% or a 10% reduction. What I care about is, are we on the fastest path to get to zero? We have to minimize the cumulative emissions over the next century. And sometimes the best path to get to zero is not the most linear or direct one. And that's a more complicated discussion, but it's an important point. Okay, so there's this timescale, again, that we don't necessarily deal with in our policy making. This was a nice paper by my colleague Miles Allen in Nature a few years ago that showed this. And it's a very fundamental point that's at odds with a lot of the conception of climate policy, including the whole Kyoto framework, which focuses on carbon emissions, not cumulative emissions. Now here's the most depressing part. What's the timescale for actually this process of decarbonizing? I want to just give you a very rough estimate. I teach a course for undergraduates and graduate students, actually. I teach two separate ones, where one of the exercises in this course is for freshmen and sophomores. They have to model quantitatively a low-carbon economy for the US. Sector-specific, transportation, residential and commercial, industrial, electricity. It's a very difficult exercise. Most people actually have never done it. And if you do it quantitatively, what's so interesting is the students become little energy wonks. They learn all about the system, and then they come together and propose their different solutions. And some of them like one technology or another, but when you put them all together, and this typically has 60 or 70 students in the class, you see the commonalities. You see actually the nature of this problem. And let me just give you that answer very quickly. So let me just show you. This was with the US transportation sector in 2008. This is the fuel, and this is the energy. The unit is gigawatt years. The reason is we're going to talk about electricity capacity. That's where we're going. And so gigawatt year is a nice unit of energy because it tells you how many gigawatts you need running at 100% capacity for a year. So this is, you can see in the transportation, it's mostly oil. And the general strategy for every sector is basically to electrify as much as you can and then decarbonize the electricity sector. That's the general strategy. So you electrify as much as possible. So we're just going to assume that some form of electric cars are going to work out, whether they're electric cars with batteries or whether they're electric cars with fuel cells. That's, let the market figure that out. But that's going to be the strategy. Motor gasoline is roughly 50%. So we're going to only replace 50% of US oil in transportation. That adds about 450 gigawatt years of electricity demand. Okay? That's, by the way, assuming unbelievable efficiency gains. So we're going to assume that efficiency gains cancels out all growth for the next century, which is, there's no chance of that doing, but let's just be super optimistic. Okay, so this is a very conservative estimate. And so you need to add biofuels as well, which is a challenge. That's, by the way, where you need carbon capture and storage for your biofuel refactories. Residential and commercial sectors, that's where we get our energy from. You can see dominated by natural gas and electricity. Electrify as much as possible, add about 300 gigawatt years of electricity demand. Okay, and the same is true in the industrial sector, which is more complicated. It's not clear you can electrify as much, but let's electrify half of it, add another 250 gigawatt years. Okay, you can see where this is going. Ultimately, here's the electricity sector in 2008. We have 1,100 gigawatts of capacity, producing about 450 gigawatt years of electricity. We have to replace all of that, so creating a non-fossil electricity sector to replace just the existing system with a lower capacity factor, because solar and wind naturally have lower capacity factors because the sun doesn't shine all the time and the wind doesn't blow all the time, means you need something like 1,500 gigawatts of new capacity. On top of that, there's that additional roughly 1,000 gigawatts, and that's conservative, of additional demand from the other sectors. So that requires an extra 2,500 to 3,000 gigawatts. So overall, you're talking about 4,000 to 5,000 gigawatts of new capacity. And that's conservative. That's with perfect efficiency gains balancing all new demand. So assuming massive political will, So the current rate of gross construction in the US is about 20 gigawatts a year. In China, it's about 100 gigawatts a year, maybe 120, depending on who you count. So assuming massive political will, perfect politics, perfect economics, perfect technology, and we spend the next 20 years building cement factories and steel factories so we could build at the rate of China, it would then take us, after 20 years, 50 years to do it. So the minimum possible with perfect politics and economics is 70 years. That's why this is so depressing. That's why this is different than gay marriage, different than civil rights. The timescale of actually making the change is inherently limiting. I mean, there is a long timescale associated with that, and we have to be conscious of that. This is a long war. This is not a short battle. So I've been thinking about that, thinking about how to think about this long war, and what is the strategy for dealing with that. It makes social movements very difficult because, Bill McKibben's out there saying no pipeline. I actually support the pipeline for reasons that I'll try to explain later. I support the pipeline because I care about solving this problem so much that I actually see blocking the pipeline as potentially doing more harm than good, but I'll explain that later. But the point is, it's very hard to get people motivated and angry for 100 years. So let's be really honest. Oh, there's some other things I should just mention. If you actually look at CO2 emission scenarios, this is from the IPCC, there's some good news. The very high, this is the emission scenarios they use, and these scenarios, these very high ones, actually are never going to happen. That's the good news. And the reason is that they actually, if you look at them, they assume wild economic growth rates and income convergences for the poor countries of the world, so that essentially by the end of this century, the poor countries of the world are richer than we are today in the US. I find that highly incredible. Maybe it'll happen, but I doubt it. I think these middle scenarios are much more likely, but it's likely we will go up more slowly and then stay that way for a very long time. So it's not going to be done in 100 years. It's going to go out a lot longer. So an honest, albeit depressing view of the climate problem, we are asking people, in general, to bear costs, sometimes significant costs. Think of how much a new Tesla costs compared to a Ford, or even compared to a fancy car, an Audi. It's pretty expensive. We're asking people in general to bear significant costs for benefits that will have virtually no impact on their experience of climate change in their lifetime. Sometimes the problem of climate change is framed around, if only the climate scientists could be a little more clear, if they could explain the problem more clearly, then everybody would listen. I think Mitch's point today was really important, where Mitch said, look, you've got to be careful how you talk to my constituency. But I think it's more fundamental than that. People scratch their heads and say, why don't people do what's right? Well, maybe they're rational. It's hard to accept, but in fact, maybe they actually don't value the future as much as some of us do. The benefits will go to their children, to their grandchildren, and beyond. And only a little bit to their children, mostly to their grandchildren. That's kind of depressing. It's a hard sell politically, right? Okay, so what is the solution? My views of this have been evolving a lot in the last 5 years. And there are three framings of this, and there are people I could put names up here of people who kind of typify one end member. To me, these are all overlapping views of progress and of change, and they are all necessary. And to me, it's important to work on all of these. One is a view about technology. To me, Bill Gates is kind of I said I wasn't going to put names on it, but it's okay. To me, I had a conversation with Bill Gates about climate change, and he's a technologist through and through. He really sees this as a technology problem. There's a behavioral frame, and all of you think about that, and that's very important too. There's also a money and power view, which is a very pragmatic view of politics and power and money, and that's a very important framing too. And we can talk about all of those. Let me make an analogy to the population challenge. So everybody knows the problems, population bomb in the 60s, published in 68. None of its predictions came true, right? They said India could never have 200 million people because it wouldn't be able to feed itself. India is now the third or fourth largest exporter of rice in the world with over 1 billion people. Why? Well, these two guys, Fritz Haber and Karl Bosch, both Nobel Prize-winning chemists who invented the process for fixing nitrogen, making fertilizer. And then this man, Norman Borlaug. This is a picture of him in Mexico. He was the father of the Green Revolution, developed dwarf wheat in Mexico and then other dwarf species. And what happened was amazing. This is wheat yields in developing countries from the 50s through 2004. Really amazing. Notice it's plateaued, which is sort of interesting. I should have updated this. I'm sorry, it only goes to 2004. But you see, it's quite amazing that we're actually able to feed the world at all. Ehrlich wasn't wrong in 68. He's just wrong today. So the question is technology the answer? Take a look at this quote. The Green Revolution has won a temporary success in man's war against hunger and deprivation. It has given man a breathing space. If fully implemented, the revolution can provide sufficient food for sustenance during the next 3 decades. But the frightening power of human reproduction must also be curbed. Otherwise, the success of the Green Revolution will be ephemeral only. That was Norman Borlaug in his Nobel Peace Prize acceptance speech in 1970. Sort of interesting. And I think this is an important thing. Think about the interplay of technology, of the Green Revolution, of nitrogen fertilizer, which allowed the world to get to 7 billion people. But in some ways, we're left with the same basic problem. We've just pushed the limits a little bit. But the fundamental problem is still there. And I think there's an important analogy there. And I've got to say, my thinking about climate change and behavior has been deeply affected by a guy named Andy Hoffman. I don't know how many of you know Andy. He's kind of a hero of mine at the University of Michigan. He's at the business school. He's very articulate, and he's very thoughtful. This is a quote from his paper where he basically, he talks about the tobacco analogy with climate change, which he says is lousy because tobacco is irrelevant to our economy. He said a much better analogy, not a perfect one, is slavery. Slavery in the 18th century in London, think about it. There were very few abolitionists, and people didn't view slavery as a moral issue. It was not a moral issue, it was an economic issue. And their economy depended on it. And if you had said, we want you to end slavery, people would have said, that's crazy. Our whole economy depends on it. What are you talking about? Well, I think to me, it was a little bit of a useful analogy because it makes everybody aware of how deep the climate problem is and how difficult it's going to be to solve and what a long war it's going to be. We did fight a war over slavery. I don't know. You could argue we have fought wars over climate change, but we'll find out. We may fight more of them in the future. But to me, this is a very, very compelling quote. And it also raises the question of this moral value. Will people in 100 years look at us with the same incomprehension we feel towards 18th century defenders of slavery? If we are to address the problem adequately, the answer to that question must be yes. So how does that change occur? This I love, this cartoon. This is from 1861, from Vanity Fair. This is the whales having a ball to celebrate the discovery of oil in Pennsylvania. Think about that, though. We didn't end whaling because we decided it was wrong. We ended whaling because we discovered a cheaper form of oil. It's a technology view. But of course, following that, we viewed killing whales as wrong, thanks to Greenpeace and a lot of other people. But it's interesting how moral values and technology and history and economy all intersect. And I think that's a really interesting area of discussion, obviously one that the Garrison Institute cares about. So here are some observations, and people may give me a hard time about this. Please don't, because I don't claim any expertise on these issues. But it's some observations and thoughts that I've been having, thinking about what I've been hearing and from previous interactions with people like Andy Hoffman. That collective action, and this is the greatest collective action problem we've ever dealt with, is easiest if one can frame the action as aligned with core cultural values. And these core cultural values can change, driven by technology, by economic forces, by social forces, but this generally takes a long time. And the relationship between technology, behavior, values, culture, political action is complex and worthy of a lot more attention. And thank you to the Garrison Institute for focusing on all this because not enough people are. Which gets us back to the point, which is preparing for climate change. So John Holdren, my former colleague and now President Obama's science advisor, has always said, and this quote goes back at least a decade when I first heard him use it, there are three ways we can deal with climate change. We can mitigate, we can adapt, or we can suffer. And we are likely to do all three. And to me, that's a very interesting perspective. There's historically been a lot of tension between adaptation and mitigation because the mitigation people felt like focusing on adaptation was like what George Bush said, we'll just adapt to it. We don't need to mitigate, we'll just adapt. And so there was this hostility between adaptation and mitigation. The adaptation community, Missy's here, the adaptation community still feels a little bit like they don't get enough of their fair share, and there's still that tension there. I want to talk about a different term, adaptation versus preparedness. Climate preparedness. This is a word that I actually first heard talking, where's Peter Lehner? Peter, back there. So I actually was on the phone with Peter, and Peter's like, we're talking to the green groups, and the green groups are all talking about shifting to the word preparedness. And I was like, what's a word? Who cares about a word? But Peter, I am educable. It's difficult, but I am educable eventually. I listen, and just not right away. The preparedness term actually is really important. Preparedness framing aligns public action on climate change with core community values, protecting your family, protecting your home, protecting your community. Preparedness, that's what the Boys and Girl Scouts do, right? That's a pretty core value. Adaptation, well, for some people, maybe some of the people that Mitch was talking about this morning, adaptation has a Darwinian connotation that's a little uncomfortable. But even for people who are scientists, evolutionary biologists who love Darwin, adaptation sounds painful. Adaptation, sounds like they're making you change. Preparedness is a much more positive word. And words are important. Take this from somebody I listened to. No, not really. I was thinking about this when Lisa was talking today about gay marriage. So this is a great quote from Rush Limbaugh on gay marriage the other day. He said on the radio, "The issue is lost. I don't care what the Supreme Court does. This is now inevitable, and it's inevitable because we lost the language on this." What he said was, we lost the language, and they defined it, they meaning the gay marriage advocates, defined it about fairness. And there's two really powerful lessons from that. Limbaugh is acknowledging that, one, aligning things with core social values, fairness, is a really powerful way of getting people to embrace change. And number two, that words matter. And they won the language battle on this. So I want to win the language battle here, and I think a focus on preparedness does a lot of things. One of the other things it does, it finesses the question of causation. It finesses the question of, is this storm caused by climate change or not? And it's fun to sort of throw that question to my colleagues and watch them fumble around for 5 minutes as they try to answer it. No scientist does a good job answering that question. And I don't do any better, but the truth is that the way I've been thinking about it is, the whole climate system, the whole Earth system is so interconnected in so many complex ways. It's completely perturbed by our actions with the atmosphere. So that everything is now affected by climate change. But is this tornado or this thunderstorm actually caused by it? That's a very complicated discussion. Take Sandy, for example. Here's Hurricane Sandy. There are two ways that I think mechanistically I can point to it and say, this is connected to climate change. One is, this is a sea surface temperature map of the Atlantic. Here's the coast of the US. And you see these very warm waters. The water, this is October 28th, the water off the coast of the Carolinas up through New Jersey was about 4 degrees above average, long-term average. So it was very warm. And that affected Sandy in that it actually strengthened from the Carolinas up to New Jersey. It didn't weaken like it should have at late October storm. The other is this left turn that it took. A colleague of mine, Peter Hybers, has been working on the hypothesis that sea ice decline from the Arctic is actually affecting the weather patterns and steering storms into the East Coast. People are still studying this, but it's, again, another example. But the climate preparedness thing finesses that all together. So this past March, we released a letter. I serve on President Obama's Council of Advisors on Science and Technology, and we released a letter where the first recommendation to the president for his new term on climate change was to focus on national preparedness for climate change. And I want to point you to this. National preparedness should be a central pillar of climate change policy. And we were thinking about this exactly, that the president needs to have something that has broad political support. And also, frankly, we need to do it. We heard from this today from a variety of people that climate preparedness is actually useful. But here's the very important, more subtle point that I think Elke's gonna talk about more in detail. Preparedness against major threats is a critical responsibility of the federal government working with the states. An ongoing focus on preparedness will help Americans understand that climate change is a clear and present threat whose effects are already visible, expensive, and worsening, rather than a distant issue with impacts many decades hence. A preparedness strategy that engages state and local officials, as it must given the geographic variation in climate change effects and vulnerabilities and the need for state and local actions to address them, will also strengthen the national constituency for the comprehensive approach to climate change, mitigation as well as adaptation that is needed. So the idea here is, how do you actually get people to focus on this challenge for decades to come? The answer is, you make it local, you make it about core values, and as people learn about the nature of the threat, as they're putting sump pumps in their basement and thinking about protecting their communities from fire if they're in Colorado or from flood if they're on the coast of Massachusetts, as they learn about the nature of the threat, they, we think, are more likely eventually to say, you know, maybe we should actually do something about the problem. And we'll soften up their attitudes towards that. This is a long-term strategy. That's not a short-term strategy, but it's a long-term strategy to build a long-term political consensus in this country, which has been a huge challenge. So there are a number of ways. I'm going to skip some of this stuff because I'm running out of time. But I want to distinguish between resilience, which is sometimes used to refer to both resilience and robustness. Robustness being protecting from damage, resilience being recovering from damage. Those are two very different terms, used sometimes synonymously, but they really should be separate because we need both of them, and they are very different strategies. But the most important policy measures, in my opinion, are those large ones like insurance policies that encourage people to live in harm's way today. So, you know, there's zoning, there's building codes, but deregulation of the insurance industry, inclusion of risk in housing markets, all of those things we need to think about as long-term policies that will encourage people to make smart decisions. My own view, I taught a course with a couple of design school professors and a couple of law school professors looking at how Boston will protect itself. Boston is actually one of the most protectable geographies because of the Charles River Basin, but it would require a big dig like $20 billion new dam out at the airport with locks to open up for the shipping to make that a reality. There is no way that's going to get built. And Boston's easy compared to most other cities. So my own view is sort of evolving in this, but it's that we're not going to do these mega infrastructure projects. We're more likely to do small stuff, and that's again why things like insurance policy and building codes really matter, because it gets people like you to do the right thing on the buildings you built, right? Okay. Climate preparedness requires a focus on local scales of climate change, and Elke will talk about this a lot more. I am part of a climate advisory board, climate adaptation advisory board. I'm happy to say they're thinking of changing their name to Climate Preparedness Advisory Board for the city of Cambridge, which includes Jake Jacoby and a few other people. Cambridge has a lot of good resources to draw on between MIT and Harvard and BU and a lot of other universities. But they hired a consulting firm to do these downscaled models of Cambridge weather in 2050. And that seems to be the state of the art right now. And it's great, it makes people see the local weather. It's total garbage scientifically. There's no scientific skill at that level. So we have to make things local, but we have to beware of the dishonesty of pushing these models beyond where they can go. I think much more useful is to think about scenarios. What if we had storm surge in Boston like we had in New York? What would it actually do? How would you think about it? And then, what are the investments you could make that would minimize the damage? Make it more robust and more resilient in terms of recovery. And one final thing I want to deal with, which is this. This is also from that report, and I'm embarrassed because we used the word adaptation, which we shouldn't have used. So this is an edited version. As the nation continues to address the challenges of preparing for the impacts of climate change, we cannot lose sight of the overarching importance of mitigating the pace and ultimate magnitude of the changes in climate that will occur. Without very substantial mitigation, which must occur worldwide, preparedness efforts will ultimately be overwhelmed. And this is my last slide. I want to show this because people have talked about, well, what do we do? What's the long-term strategy? There isn't time to talk about it here, but the first step to me in the US, and this is a US view, but the US needs to shut down its conventional coal plants. We need to do this for health reasons. This is a famous old study that everybody should know, and the fact that they don't, to me, is a problem with our communities. This is a guy named Pope, who is at Brigham Young. This is a study of Utah Valley, which has a wintertime inversion, so the local air pollution is very important. A single steel mill contributed about 30% of the particles in the air, coal burning. And so it got shut down in the winter of 86, 87 because it was a strike. You can see this is the particles in the air in 86, 87. Here's children admitted to the hospitals for bronchitis and asthma and pneumonia. Burning coal is really bad for children. It makes sick kids. But the Republican primaries last year, every candidate was talking about shutting down the EPA. This is astounding to me. Now, the problem is, this is a battle that we should be able to win easily, and we're having trouble. We're having trouble shutting down the dirty conventional coal plants. It is the linchpin of future for all sorts of reasons, and many of you understand why this is the first step towards decarbonizing in the US. We can't even do this with the health impacts at our backs. The wind is at our backs on this one, and we can't do it. We've got a lot of work to do. So I'll stop there and pass it on. Thanks.